morning to Miss Irma. I am Nivashni and today I would like to present about thin layer chromatography, which is known as TLC. The sample that we used for thin layer chromatography is fresh green leaves. Next, let's see the technique used in analysis of sample. We can analyze the sample in thin layer chromatography by two types of analysis, which are qualitative analysis and quantitative analysis. The technique used in quantitative analysis is direct technique and indirect technique, while the technique used in qualitative analysis is retardation factor, which is known as RF value. Now let's see the definition of quantitative analysis and qualitative analysis. Quantitative analysis is any method used for determining the amount of a chemical in a sample. The amount is always expressed in a number with appropriate units. And qualitative analysis is determination of non-numerical information about a chemical species or a reaction. For example, observing that a reaction results in a color change. Next, let's see the definition of techniques used in the analysis. First of all, direct technique. It means quantitative determination is undertaken directly on the layer. Next is indirect technique, which means the substances are removed from the absorbent and then determined after the elution. And the last one is retardation factor, which is known as RF value. It means fraction of an analyte in the mobile phase of a chromatographic system. That's all. Thank you.
Hi, I am Noor Arga Tasnim. My metric number is DB23DBT18F1023. Today I would like to present about my slide, that is preparation of samples. Firstly, we have to collect the fresh leaf and put it into the chamber and vessel to be crushed. Then the stationary phase is applied onto the plate uniformly, then allowed to dry and stabilize. Then thin mark is applied at the bottom of sample spots with a pencil. Then the sample solution are applied on the spots marked on the line is equal distance. Then the mobile phase is poured into the TLC chamber to a level a few centimeters above the chamber bottom. A moistened filter paper in mobile phase is placed on the inner wall of the chamber to maintain equal humidity. Then the plate prepared with samples spotted in place in TLC chamber, so that the side of the plate with the sample line is facing the mobile phase. Then the chamber is closed with a lid. Then the plate is then immersed such that the sample spots are well above the level of mobile phase for development. Finally, allow sufficient time for the development of spots. Then remove the plate and allow them to dry. The sample spot can now be seen in a suitable UV light chamber or any other methods as recommended for the sample. This is the possible result that we may get. There you can see that there's a few spotting here.
That's all. My name is Anusuya and my metric number is 1039. Today I'm going to present you about the method of analysis in thin layer chromatography. Well, there are two types of method of analysis in this TLC, which are the quantitative analysis and also the qualitative analysis. Now let's look at the quantitative analysis. There are two ways to identify the quantitative analysis, which are the direct technique and also the indirect technique. Now the direct technique is about the densitometer, which is an instrument can measures quantitatively the density of the spots, and the quantity of substance can be calculated, and the optical density of the spots for the standard and also the test solutions can be determined through this direct technique. And the second one is the indirect technique. The indirect technique is basically how the spots are cut into the portions and eluted with the solvents. And these solutions can be analyzed by any conventional technique of analysis like spectrophotometry and also electrochemical methods. So basically, the quantitative analysis is how the paper and also the thin layer chromatography can give a rough idea on how much based on the intensed on the colored spot is. And sometimes the spots can be removed and processed to find the accurate amount and giving the quantitatively data. Okay, now about the qualitative analysis, it's mainly focusing on the RF value, which means the retardation value. Okay, for first one, the retardation factor is about to calculate it to identifying the spots and the ratio of distance traveled by the solute to the distance traveled by the solvent front. When the RF value of the sample and reference compound is same, the compound is identified. So basically, the RF value is actually from 0 to 1, but the ideal value is from 0 to 0.3 to 0.8. And then the RF value is constant for every compound, in particular combinations of the stationary and also the mobile phase. Okay, now let's look at the suitable parameters for the thin layer chromatography. For the first one is the type of chromatographic plate. It could be the handmade and also the pre-coated thing. And the second one is the partial size distribution. It should be white. And the third one is the partial size range is between 5 to 20 microliter. And the shape should be spot. The spot size is between 2 to 4 millimeter. And the layer thickness is 250 microliter. And the solvent consumption is 50 milliliter. The number of samples should be maximum 12. So it should be like minimum more than 12. And the optimum development distance is 10 to 15 centimeter, and the sample of volume is 1 to 10 microliter. Thank you.
Hello to Miss Irma, my name is Avendil Diamond, and today I'll be talking about thin layer chromatography. So basically, in my part of this presentation, I'll be talking about the possible results and how thin layer chromatography can be used to improve the environment. Okay, so for this slide, the possible results. These results was obtained when we did this experiment in Polytechnic. Basically what we did was, we took fresh leaves from the plants outside and we grinded them with two different liquids actually. So basically the first liquid was grinded with the leaves to make mixture 1. The second liquid was grinded with the leaves to make mixture 2, and both liquids was mixed and grinded with the leaves to make mixture 3. So basically each of these liquids was tested by dropping one drop of the liquid onto each piece of paper. So basically there's 3 pieces of paper and each mixture was dropped onto one. So mixture 1 was dropped onto paper 1, mixture 2 was dropped onto paper 2, and mixture 3 was dropped onto paper 3. So basically what we did was, we took these papers after it was dropped and we put them into glass cases basically, and we poured into the glass container the same liquids that was mixed with the leaves. So liquid 1 was poured into the container that contained paper 1, liquid 2 was poured into the container that contained paper 2, and liquid 3, which is mixture 3, that was poured into the container that contained paper 3. So basically what happened was, the drops that had the leaves, that had the essence or had the properties of the leaves that was grinded, basically it would rise up. So this experiment or this method was used to find out how much of difference there was in each liquid to make the properties of the leaves go up in the paper. So basically in this experiment we can see that the first mixture showed a very high difference, that the liquid pulled the droplet up. Secondly, there was a average distance that the liquid pulled the droplet up, and the third mixture showed very little movement from the starting point until the point where it stopped. Okay, after the possible results, we'll be talking about how this technique can improve the environment. Okay, so this technique can be used to separate all classes of natural products. So basically, we can take a substance, we can take any sort of substance, and we can put it in this method to basically find out what is in that substance, or what is in that liquid, or what is in that compound. Basically we can identify individually what is in that product. So basically, as I have written here, we can use it as an analytical tool. So what that means is we can use this to analyze what is in a product. We can list out, okay, there is this type, there is liquid X here, there is liquid Y here. So basically from that one product we can list out all the little sub contents of that product, and we can find out what is in that actual product. So basically this product, as my second point is, this product can be extensively used as a purity testing product. So basically we can test how pure is this product, how original is this product, what is in that product. So basically for the environment, this can be very beneficial because it can tell consumers, or it can tell the producers that, okay, there is this substance in this product, and then the consumers or the producers can look at it and say, okay, this is not good for the environment, so we have to change it. So basically they can test what is in their product, and they can make changes to better the environment. Okay, this is all from me. Thank you.